We're up to one of the trickiest parts here of graphing a quadratic. And this is where you've got a quadratic function, but it's not already factored. If it was factored, we'd have something like this, which is nice. You know, two things multiplied together, and we could graph it with this strategy, blah, 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 blah. But here, it's not factored. It's expanded out, which means that finding the x-intercepts will be a little bit tricky, but still possible. Finding the y-intercept though, so that we can sketch this, works just the same as we saw in the last video. A y-intercept is where the quadratic crosses the y-axis, and the y-axis has an equation of x equals 0. So to find the y-intercept, let x equal 0. We're going to rewrite this equation and replace x with 0. So the y will still be there, minus 2x, I'm replacing with 0, and then I've got the squared there. Oh, hang on. What have I forgotten in the middle here? This means negative 2 times x squared. There's an invisible times sign between the number and the letter. So let's put in the invisible times sign. Okay, let's do the next bit now. Negative 12, replace x with 0. Hang on, this isn't 120. Between the number and the letter, there is an invisible times sign. And then I can copy down the negative 18. Cool. So if x is 0, then this is true. Now we can figure out the right-hand side, because this is just arithmetic. You could put it in your calculator, or you can notice that this is something times 0 squared. So this will be 0, and this will be 0. The only thing that will be left is that y equals negative 18. But pop it in your calculator to double check. So what we've learned is that if x is 0, then y is negative 18. Or 0, negative 18, I don't know, somewhere around here, is a point on this parabola, on this function, on this quadratic function. So we can plot the point there. Let's label it as negative 18. It says here to sketch the quadratic function. When I say sketch, I mean it's the right shape and is fully labeled, especially the axis intercepts are labeled. Okay, so I've got that there. Now let's find the x-intercepts to get a feel for what this quadratic looks like. To find the x-intercepts, to help us graph the function and get an idea for what it looks like, the x-intercepts are where the parabola crosses this line. And for every point on this line, it's true that y equals 0. You know, the y-coordinate of this point here is 0. So to find the x-intercepts, we let y equal 0 and substitute that into our equation. Let's write our equation again, but instead of y, I'm going to write 0. And we'll just see what happens. So I've copied this down here. So if y is 0, then this equation is true. And if this equation is true, I could actually solve it to figure out what x is. Now, if you haven't already seen how to solve quadratic equations, how to factorize quadratic equations, and how to take out the common factor here, you're going to have to go back, and I'll leave links in the description if I remember. If not, please hassle me so I do. To go back and learn how to solve this equation, because this is just going to be too quick for you to get the full concepts, but I have more videos that talk about that. Okay, so 0 equals this whole thing. To solve this, I've got a range of tools that I can use. One tool is I can take out a common factor. There is a factor, a number, that goes into each of these things. Something that goes into this, and it also goes into this, and it also goes into this. And that factor is negative 2. This coefficient here of negative 2 also goes into negative 12, and it also goes into negative 18. So now I will write this expression here, this expanded expression, but I'm going to take a common factor, the negative 2, out the front. So what goes here, negative 2 times something is negative 2x squared. The something is x squared. Negative 2 times x squared gives me that. Okay, what about the next one? -2 times something gives me -12x. One way to think of it, a negative and a negative is a positive. 2 times 6x is 12x. So you can focus just on the sign first, the positive, then 2 times 6 is 12, and then I would need the x there to end up with an x here. Just to show that, -2 times 6 is -12, and then put the x on the end. So that checks out. The last one, -2 times something is -18. A negative is a positive, and 2 times 9 is 18. Let's just double check. -2 times +9, it really is -18. Yeah, negative and a positive is a negative. 2 times 9 is 18. Good. So these two equations are the same. They're the same equation, just written differently. Now we can use a different trick, which is to factorize this. And there are a few ways to factorize it. I'm going to choose to factorize it using the sum and product method, looking for two numbers that add up to give 6 and multiply together to give 9. Those two numbers are 3 and 3. 3 plus 3 is 6. Good. 3 times 3 is 9. So again, if you're not sure about sum and product, go back. Watch my video on sum and product, where I go in a bit more detail. So now, in other words, I've replaced it because that expression is equivalent to that expression. So I've replaced it with an expression that's the same. And now our good old loyal friend, the null factor law, either -2 is 0, which is impossible, or x is -3. That's the only solution. X is -3 or x is -3. So the x-intercept is x equals -3. And there is only one. There's only one x-intercept. -3 might be about like here, I suppose. So let's label that x-intercept, which is -3. It's called an x-intercept because it's on the x-axis. And because we know that there is exactly one x-intercept, that means that the parabola is symmetric about this line. Yeah, this is the axis of symmetry. So if the parabola is coming up here and going, wee, whoa, oh, please try to draw a neater one than this. It's just really hard on my touchpad to draw a good parabola, and then comes back around and should be perfectly symmetric. A lot like this. There we go. So can you see that by drawing the dotted line or imagining the dotted line as the axis of symmetry can really help? Now, you could pretty much sketch and imagine and draw and visualize and explore pretty much any quadratic that I throw at you, which is a cool skill to unlock on your skill tree of mathematics. Yes, helping you understand the visual side of algebra. Anyway, I hope this has been helpful. Let me know if you have any questions. Good luck, everyone. Bye.